Incredible present, paralyzed people have begun to control prosthetics with the power of thought, play computer games, chess, and control a computer mouse. This is already happening with the help of brain implants from companies like Neuralink, Synchron, and Johns Hopkins University. What comes next? What are the prospects for this technology, and is this the beginning of the cybernetization of society? Or is it a path to a new form of slavery? Let's find out. Noland Arbo is the first patient with a Neuralink implant. His story is impressive. After the surgery, he could control a computer mouse with just his thoughts. Neuralink, founded by Elon Musk, developed a chip with 1024 electrodes that read neural signals and transmit them to external devices, allowing the user to control them without physical actions. This opens up immense possibilities for people with disabilities. Another impressive example is a patient with a brain implant from Johns Hopkins University. He successfully controls two prosthetics simultaneously, using only his thoughts. This allows him to perform complex tasks, such as tying shoelaces, without needing visual control. The integration of touch sensation makes controlling the prosthetics even more precise and natural. Another fascinating case is a Synchron patient, paralyzed from the shoulders down, who managed to play a game of chess on a computer. This was made possible by an implant that allows neural signals to be transmitted to external devices, opening new horizons for rehabilitation and improving the quality of life. How do brain implants work? Brain implants work by reading neural signals and transmitting them to external devices, such as computers or prosthetics. These implants can be invasive or non-invasive. Types of brain implants. Invasive implants, these require surgical intervention to place electrodes in the brain. For example, Neuralink implants are inserted directly into the cerebral cortex, allowing high-precision signals to be read and transmitted to external devices. Non-invasive implants, these use external devices to read brain signals, such as electroencephalography, EEG. They are less accurate but do not require surgery and can be used for less complex tasks. Surgery for implant placement. The procedure for placing an invasive implant includes a surgical operation, during which the skull is opened to insert electrodes directly into the brain. For example, in the case of Neuralink implants, a surgical robot inserts thin electrodes into the brain, avoiding blood vessel damage. The procedure takes several hours, and after placement, the implant must be configured for proper operation. Prospects and timelines. Brain implants have enormous potential for treating neurological disorders and improving the quality of life. It is expected that within the next 5 to 10 years, they will become more accessible and widely used. However, before mass implementation, it is necessary to address safety and ethical issues and conduct more clinical trials to prove their effectiveness and safety. Cost of implants. The cost of brain implants can vary significantly depending on the type and complexity of the device. For example, the development and installation of a single Neuralink implant can reach tens of thousands of dollars. Mass production and technological progress can reduce this cost, but for now, these devices remain expensive and inaccessible to the general public. Brain implants open new possibilities for medicine and technology, but they require thorough study and discussion before mass implementation. Futurists predict that brain implants will open incredible opportunities for humanity. Here are some of the most interesting prospects. Improvement of cognitive abilities. Brain implants can significantly enhance cognitive functions, such as memory, concentration, and information processing speed. This technology can help people with neurodegenerative diseases maintain their cognitive functions at a higher level and increase the intellectual capabilities of healthy people. Telepathy and new forms of communication. Elon Musk, founder of Neuralink, predicts that brain implants will allow people to communicate telepathically. This could lead to new forms of communication where thoughts are transmitted directly from brain to brain, bypassing traditional verbal or written methods. Control over devices and virtual environments. Brain implants will enable people to control various devices and interfaces, including computers, smartphones, and even entire virtual environments. This will allow for the creation of more interactive and intuitive user interfaces and open new possibilities for entertainment and professional activities. Treatment and restoration of functions. Brain implants can restore lost functions in patients with spinal cord injuries or other neurological disorders. For example, these implants can help paralyzed people walk again or control limb prosthetics, restoring their independence and improving their quality of life. Brain-computer interfaces for enhancing capabilities. Brain-computer interfaces will allow people to integrate with artificial intelligence, which can significantly expand their capabilities in various fields. From science to art, this can lead to new forms of creativity and innovation, where humans and machines work together in synergistic combinations. Medical diagnostics and instant treatment. Brain implants can be used for instant diagnostics and treatment of mental disorders. With this technology, doctors will be able to quickly determine the patient's condition and provide targeted therapy, significantly increasing the effectiveness of treating disorders such as depression and post-traumatic stress disorder. Challenges and ethical issues of brain implants. Brain implants promise revolutionary changes, but they also raise serious challenges and ethical issues. One of the main problems is security and privacy. How to protect these devices from hacking. It is important to ensure user safety so that their personal data is not compromised. This problem becomes increasingly relevant with the development of technologies capable of reading thoughts. Social issues. Access to brain implants may deepen social inequality. If such technologies are only available to wealthy people, it will lead to a new form of social discrimination. It is important to ensure equal access to these innovations so that everyone can benefit from their advantages. Ethical issues. Brain implants raise important ethical questions. Some scientists are concerned about the possibility of interference in personal life and manipulation of users' free will. For example, there is a risk that these devices could be used to control or influence a person's thinking, violating principles of autonomy and privacy. Views of opponents and supporters. There are different views on brain implants. Some people see their enormous potential to improve the quality of life. They are excited about the possibility of treating neurological disorders, enhancing cognitive abilities, and creating new forms of communication. For example, Neuralink founder Elon Musk believes that these technologies will help humanity keep pace with artificial intelligence and provide new opportunities for interacting with technologies. On the other hand, critics are concerned about possible negative consequences. They point to ethical problems and risks related to safety. For example, Ryan Merkley, director of research advocacy at a medical ethics organization, expresses concerns about the transparency and safety of Neuralink's research. He emphasizes cases of negative consequences for test animals during tests, which raises doubts about the readiness of the technology for human use. Conclusion: brain implants have great potential, but they also raise many questions. Do you think the advantages of these technologies outweigh their risks? Is society ready for such innovations? Leave your thoughts in the comments, like, and subscribe to our channel to not miss new videos about the most interesting technological achievements.